everyone, my name is Sandeep Bhatia, Assistant Professor in the Department of Electronics and Communication Engineering at Rajkumar Goel Institute of Technology, Ghaziabad. So, in a series of lectures delivering for a subject microcontroller and its embedded systems having code KEC 061, what we have covered? We have covered most of the topics of unit number first, and in the previous lecture we have started with the advanced microcontroller, that is AVR microcontroller, and today we will learn some rest of the things of AVR microcontroller. So, in part 2 we will discuss the various applications of AVR, some more things about the AVR microcontroller. So, these are the table of contents we will cover in today lecture, that is AVR ALU. In our block diagram or we can say architecture of AVR, we see that the role of the ALU, arithmetic logic unit, AVR memory access, instruction execution of AVR we will cover in this lecture, and timers in AVR and interrupts in AVR. So, we will cover AVR, the total explanation of the AVR in this lecture. Okay. So, these are the table of contents. So, start from the 8-bit AVR arithmetic logic unit. So, basically what is 8-bit? In previous lecture we have seen that AVR is a 8-bit microcontroller. 8-bit microcontroller means that it works on 8 bit of data at a time, and in previous lecture we have seen that AVR has 32 general purpose registers, 32 general purpose registers. So, varies from R0 to R31. You can follow my previous lectures for the detailed explanation of the AVR microcontroller. So, basically what is the role of the ALU? ALU performs, A stands for the arithmetic, L stands for the logical, and U means unit. So, basically this ALU unit perform the arithmetic and the logical operations. Arithmetic operations like addition, subtraction, multiplication, division, all these operations are carried out in a ALU unit, and L means the logical operations like OR and XOR etc., which are associated with the logical gates. Okay. These are performing logical operations. So, basically ALU unit carry out these operations, and we have seen in block diagram that the result of the ALU is further provided into a 8-bit data bus. Okay. So, basically this the high performance AVR arithmetic and logical units operate in direct connection with all the 32 general purpose working registers. So, in this block diagram you can see that this is a ALU arithmetic logical unit. The representation of ALU is like this. It basically it means it is summation. It is doing some arithmetical and logical operations. It is not like the rectangular blocks or other square box etc. Okay. So, it has ALU represented like this. Basically this means there is something arithmetic and operations are doing here. So, it has a sign of summation. It has a sign of summation. Okay. It has a sign of summation. So, there this is doing some operations. Let us consider x here and y here. Okay. So, when the data who is provided the data to the ALU, 32 into 8 general purpose registers are providing data to the ALU. So, let us write here 32 into 8. 8 means that the registers 32 general purpose registers, that is from R0 to R31, total 32. So, each register is of 8 bit. So, we are saying 32 into 8. It means that we have 32 general purpose registers in case of AVR microcontroller, and each register is of 8 bits, that is we are writing 32 into 8. If we are writing 8 into 8, what does it mean? It means that it has a 8 general purpose registers like 8051 microcontrollers, we have R0 to R7 general purpose registers available, and each register is of 8 bit. So, meaning of 32 into 8 you have clear. Okay. So, basically 32 into means that it has a 32 general purpose register and each register is of 8 bits. So, we are providing who is providing data to the ALU, 32 into general purpose register, the data stored into the 32 into 8 general purpose register are providing data into the ALU. So, let us take here x and y. So, the ALU operations are performed into these two signals x into y, whether it is x plus y addition, whether it is x into y and operation, let us take x division operations. Okay. So all the operations are carried out in ALU unit. Okay. So when ALU do some operations, there is some result, and the result is further provided into a 8-bit unit. So basically this is 8-bit wide, and when we are doing some operations, some carry may be generated. Okay, when we are doing some operation, let us consider that if we are doing arithmetic operations, that is addition operation x plus y. So there is chance that some carry generated. So these flags are used to point out to the carry. So there are some status register, H register, S registers, V, N, Z, C, all are status registers. Like microcontroller, we have seen that there are some status registers available. In AVR microcontroller, there are some registers available. And here you have seen the term flags. What is the meaning of the flags? Flags are available in the microcontroller to indicate the present situation of the microcontroller. Present situation may be that what are microcontroller doing, whether it is doing some data, whether to indicate the some condition that if we are doing some arithmetic operations, there may be a result, and these result are whether set or reset. These are this is indicated by the flag unit. Okay. So this is the basic representation of the ALU unit. Okay. So in next slide, we are going into the detailed explanation of the ALU. So we have seen that in previous lecture that ALU has a sign of summation. Summation means that it is doing ALU operations, and they are getting data. We have seen that x into y. They are getting data from the 32 into 8 general purpose register. 32 means that it has a general purpose register varying from R0 to R31 means 32, and each of 8 bits. So that's why we are represented 32 into 8. We have seen our previous lecture, and they are ALU getting the data from the 32 into 8 general purpose register and do some arithmetical logical operations. Arithmetic operation, we have seen that like addition, subtraction, multiplication, division, and after we are doing some ALU operations, carry may be generated, and it will be indicated by the flags. Okay, flags will represent the status of the ALU operations. So out means target register means that whatever we are doing, there is some result. For example, if we are adding 2 plus 3, 5 is generated. Let us take simple example, and this 5 will be stored in the target registers. Okay. So ALU is one of the most important components in a microprocessor. Without ALU, any processor cannot work. Why? Because in any processor, you need to do some arithmetic and logic operations, and these operations carried out by ALU unit. Okay. So within a single clock cycle, in a one clock cycle, what does a single clock cycle means that every microcontroller needs some clock pulses to execute, and these clock pulses are provided by the crystal oscillator. We have seen in our previous lectures. So within a single clock cycle, arithmetic operations between general purpose registers or between a register and immediate registers are executed. Okay. So ALU operations is divided into 3 main categories, whether it is doing arithmetic operations, logic operation, and bit functions, bitwise functions, basically set, reset, and some more bitwise rotate operations, logical left, logical right operations as well. So this unit can connect up to 2 values on its input lines. There are 2 values we have seen, x1, x and y. Input 1, input y 2. There obviously there should be 2 inputs. If we are adding something, there should be 2 inputs available. We are doing the arithmetic and logical operations on 2 values. Okay. So input lines 1 and 2 should be available to the ALU, and can add or subtract on doing some logical operations on these 2 inputs value x or y. So basically the ALU writes the results of the operation, for example, to a target register. We have seen that whatever we are doing arithmetic logical operations, the result will be stored into the target register. It is going into the target register. After that, the whatever the value stored into target register, it will be go into the 8-bit data bus. Okay, we have seen in block diagram. So basically it has a there are some instructions available in AVR microcontroller. In our syllabus, we have just only the introduction of these instructions. We will not go into depth of the each and every instructions. So here we can see this table represents some important instructions of AVR microcontroller. Important instructions means here you are seeing two terms, mnemonics and operands. Basically, there are two things in microcontroller. You can see in microprocessor that there are two things, opcodes and operands. What does it what does it means? Opcode means the instructions, basically instructions. What the microprocessor had to do, what the processor has to do, it is telling by the opcodes. Basically, opcode stands for operational codes. It is tell the microprocessor that what you have to do with the instructions, and to whom it will work on the operands. There are two operands available in the any processor. Okay, so let us take example MOV A, B. So MOV is a opcodes, operational codes. We can say it as mnemonics. What the microprocessor has to do, it will be tell by the opcodes. Move. So basically, we are looking into this instruction. Move means that we are moving something. We are loading the data from one register to the another register. Okay. So there are two operands A, B. What is the name of the two operands? There is a source operand and a destination operand. So we are getting the data from one operand to and move or some addition operation may be there, and so we can say that mnemonics means opcodes. Operands means we are doing operations on the operands. Okay. So description of this. So let us take one add. ADD means we are adding something. ADD means adding the the values of the two operands. RD means what does it means? There is a source operand or this is the destination operand. So we are adding the data of one register to another registers. Add two registers without carry. What will be the opcodes if in case of carry? So add two registers with carry have ADC. ADC means that AD means addition operation, C means that with carry. AD means addition operation, C means carry. So we are doing addition operation in between two registers with carry. Similarly, subtraction operation, subtract two registers, subtract two registers from some constant. Okay, constant define here. Subtract two registers with carry, subtract constant from register with carry. AND operations, we are doing AND operations, and logical AND register and constant. I means it representing the constant, I means immediate value, it is represented constant. Okay. OR operations, we are doing OR operation in between the two registers, OR with constant. Okay. EOR means exclusive OR registers, COM means one's complement, NEC means two's complement, SBR means set bit in register. Set means it has a value of 1. We are setting the things here. It should be high. CBR means clear the bits. The value of this should be 0. Clear means we are lowering the data on a particular signal. INC means incrementing the values. DEC means decrementing the values. TST means testing for 0 or minus. In microcontrollers, in some cases we need to test for a particular condition. So we are using TST for that. Clear means we are clearing the values. And SER means we are set the register. So these are the important instructions. We cannot go in the detailed explanation of this because in your syllabus only the introduction of the instructions available. Okay. So these are the important instructions. Now the next topic is AVR memory access. What is the meaning of a AVR memory access? Basically in this topic we will learn the memory allocation in our AVR microcontroller. So here you are seeing 3 blocks, basically 3 things. First, this one is the first block, this one is the second unit, and this one is the third block, we can say. Okay. In first block it is dedicated to the flash program memory. Flash program memory. In our features of AVR microcontroller, we have seen that this AVR microcontroller has a flash program memory. Okay. Flash means that it has a read or write operations possible in AVR microcontrollers. After that, second unit is dedicated to SRAM. SRAM means that static RAM memory. It is of 2 kilobytes. And third one is the input output address memory. Okay. So the address range of flash memory is from 0000 to 3FFF. Okay. And here you are seeing one thing, 16K into 16, it is equals to 32 kilobytes. What does it mean? 16K means that it has a memory of 16K, and each memory have 16 bits that means it has a 2 bytes, 16 bits. 8 bits is equals to 1 byte. Okay, so 16 bits is equals to 2 byte. So 16 into 2, how much? 32 kilobytes. Okay, so 16k into 16 means that each memory is available as a 16 kilobytes, and it is into 16 bits means it has a 2 bytes. So total is of 32 kilobytes, and each has two operations. 0, this is the 0 segment, this is the 1 segment, and it is it dedicated to application flash section. So here you are seeing the term boot flash section. Boot flash section has a range of 256. So basically 2048 words. So this is the address range, we have seen that. After that, second block is dedicated to SRAM data memory. Okay, it is of 2 kilobytes. It is of 2 kilobytes, range from 08FF to 0000. It is divided into a further subsections because memories have a sectors, we have seen that. So 2048 into 8 SRAM, okay, 160 external input output register, 64 input output register, and 32 registers. So this is the register organization of AVR microcontroller. After that, the third block is EEPROM. EEP means electrically erasable, programmable, read only memory. This is EEPROM. Okay, so it has a range of 1 kilobyte. Only 1 kilobyte available in case of we can say that EEPROM data memory. So there are 3 segments in memory, AVR memory access: flash program memory, SRAM data memory, and EEPROM data memory. Okay. So after that, we are going into the depth of the memory execution. First one is the program memory. Program memory means that it is basically a ROM memory, read only memory. Program is fixed, it is independent of the power supply. Okay. So the AVR microcontrollers contains on chip. On chip means on chip memory. It has a on chip in system programmable flash memory for program storage. So since all AVR instructions are 13 or 16 or 32 bits, we can see in our previous slide that all the instructions are available either as a 16 or 32 bits wide. The flash is organized into a 16k into 16. We have seen that either it is available as a 16 kilobyte of memory, and into 16 bits means it has a 2 bytes. So 16 into 2 bytes means 32 bits. In our previous slide we have seen that. Okay. So for software security, the flash programmable memory space is divided into a sections: bootloader section and application program section. In our previous slide you can see here. The flash memory program memory is further divided into a 2 section: application flash section, and the second one is the boot flash section. Boot memory section means that, what is the meaning of bootloader section? Basically, when we are switching off on the particular microcontroller, the first memory which is activating, that is a bootloader section. Basically, it is not possible to read and write in each particular cycle. So this is available for a long time. This is a bootloader section and application program section in the device. So the flash program memory has a typical endurance of at least 10,000 read or write cycles. So here you can see that the third section is electrically erasable PROM data memory. It is available in 1 kilobyte of package, and it has a endurance of, that is, it has a capacity of 10,000 write reads cycle, read or write or erase cycles. Okay, in a one go it can do that. Okay. So this is the AVR memory access. So another sections available: EEPROM data memory. Data memory, what is the meaning of the data memory? That is, it is indicated to RAM, read access memory. It is dependent on the power supply. Whenever if we are switch off the system, the contents of RAM will erase, it get deleted. So RAM will be activated, the data is activated whenever the power is on. Okay. So data electrically erasable programmable read only memory is organized as a separate data space in which single bytes can be read or written. So access from the CPU to EEPROM is done through the EEPROM address registers and EEPROM data registers. So when we are accessing these types of memory, we need to store the data. So in EEPROM address register and EEPROM data register, we can store the data, and the things are controlled through EEPROM control register. Whether we are read the data or write the data. These are controlled through EEPROM control registers. The EEPROM has an endurance of at least, we have seen in our previous slide that 10 hundred of thousand write or raise cycles are possible. After that, SRAM data memory, SRAM is static RAM. So data can be accessed through the standard data bus. There is a secondary input output bus for rapid direct access to selectable locations. Here you can see that this is the SRAM memory, 2 kilobytes, and it is further divided into many things: 2048 into 8 RAM, 160 external input output registers, 64 input output register, and 32 registers. Okay. So this is the again explanation of the memory. Here you can revise the things. So data memory consists of registers, input output memory, okay, external input output memory, and the internal SRAM. So registers are available, 32 general purpose registers available. That is why 32 is written here, that is from R0 to R31. 64 input output registers available, having memory from range from 20 to 5F. Here memory range is from 0000 to 1F, 32, total count on 32 memory locations available. 62FF memory range of 116 external input output, and 0100 available in internal SRAM. It is available as a 2048 to 8, that is 2048 bits available and each of 8 bit. Okay. So it has a register space of 32 general purpose register. Input output memory has a range like this, we have seen that. Okay. So this is all about the AVR memory access. So it has of sections: extended input output memory, internal SRAM, and the input output data bus. So some AVR microcontrollers with more peripheral need more space. So to handle the input output instructions, we need a extended input output memory. One of the important features of AVR microcontroller is that it has an extendable input output memory. It has an internal RAM. We have seen in our previous slide that what is the function of the SRAM data memory. It is used for temporarily storing of immediate results. We are getting data from the ALU, on the temporary basis data is stored into the SRAM memory. Input output data bus, either it is works as an input or whether it acts as an output. So it has a range from 0000 to 001F. So it has a 64 byte input output memory section. Okay. So in this slide we will see the instruction execution in AVR. How instruction execution can be done in AVR microcontroller. So this is the CPU section, and this is the program or data memory section. So these two blocks are connected through address bus and data bus. Okay. So how the execution takes place? Execution will be takes place like this. How it can be done? What is the function of the CPU? To carry out the operations, whatever we are dealing with the input, it will be carried out in CPU section. It has a program counter which point out to the instruction of the next instruction to be executed by the microcontroller. It has a instruction register, and there are two types of buses: address bus, data bus. Address bus is unidirectional, that is we are getting the data from the CPU, and CPU places the address of the particular memory segment into the address register. So there are three operations in any processor: fetching, decoding, and executing. So first is data is fetched from the data memory, and it is decoded into this section, and execution take place according to the instructions. So here instructions are available from n-2, n-1, n+1. So to which instruction the CPU has to be execute, there is some address. For example, if we are dealing with the n instruction, it has some address 4000. So who will provide the address? This address will be provided into address unit. It will go here, and from the particular instruction, for example, at memory location 4000, there is some data 4F. It will be fetched from this n memory location through this path to program counter. So the CPU present the value of the program counter on the address bus and read the control bus. So this execution is similar to 8051 microcontroller, 8085 processor. So this is the instruction execution. Okay. So the CPU present the value, we have seen in our previous lecture that CPU carry out the main operations. Okay. The flash program memory looks up the address of the instruction and present the value on the data bus. The value from the data bus is placed into the instruction register, and the CPU clears. Whenever the data is fetched from the memory location, it will be clear by the read control line. The instruction register now hold the instruction to be executed. Okay. So the program counter is incremented. What is the meaning of the program counter? We have seen that it is point out to the next instruction to be executed by the processor. So whenever the instruction is executed, it will be the program counter for each instruction to be executed, it is incremented by 1. So here it means that it is incremented, so it point to the next instruction to be executed. Instruction decoder, whatever the instructions are getting, they are decoded into these units. Okay. So this is the timer in a AVR. What is the meaning of the timer? Basically, timers are used to counting the events in a particular microcontroller. So basically, we use a timer or counter to generate time delays. So to generate time delays, to set some particular time, to count events, we need timers. So timer may be used in PWM generation. We have seen in our previous lecture that PCA timer, like it is works in the capturing mode, PWM modes, to count the events, etc. So in our ATmega 32 or ATmega 16, one of the family of AVR microcontroller, there are 3 timers: timer 0, timer 1, timer 2. Timer 0 is 8-bit, timer 1 is 16-bit timer, and timer 2 is 8-bit timer. So here timer has a range from 0 to 255, that is 0 to 2 ki power n minus 1. So whenever the timer needs some particular frequency operation, crystal oscillator providing the frequency. Okay. So whenever they are getting the frequency operation, this timer is activated and start counting the events from 0 to 255. 255 is the maximum value. When it reaches to the maximum value, what will happen? It will roll over. That is roll to the initial value, that is the overflow will be generated. And who will tell the overflow? This is will be told by the flag register. The flag register will tell the there is some overflow in the system. Okay. So it has some registers TC and T0. TC and T0 means it has a 0 value, n has a value of 0 or 1. So it has a timer counter register. Every timer has a counter timer register. So it is 0 upon reset and 1 upon set. So okay. Timer overflow flag, we have seen that when it exceeded into from its maximum value, it the overflow flag is set. Okay. So TCCRN means timer counter control register. What will do? It has to run the counter, we need to set the modes of the timer counter. This register will be used. It has an output compare register. What is the output compare register? It will compare the values of TC and T0 and OCR0 and further provide result into the OCF0. Output compare registers. Okay. So these are the timer in AVR. It is started from the 0, go to its maximum value. What is the maximum value? FF. When it exceeds its maximum value, for example, FF plus 1. So it has a 100, 1 is the extra carry. So when it exceeds its value, overflow, there is overflow in the system. So when it going to maximum value, again it will come to 0 and it will work. The waveform is generated like this. So basically CPU performing internal timer, basically to count the internal events, external counter counting the external events, and it works as a PWM generator. Okay. So when we need to generate the time delay, we need to use the timers. So overflow flag. So when it goes from the maximum value, there is a indication of the overflow. Okay. So last topic is the interrupts in AVR. What is the meaning of the interrupt? Interrupt means that whenever we are doing execution, there is certain disturbance created, it will work as a interrupts. So in AVR microcontroller, in pin diagrams you can see here, there are interrupts available. Two types of interrupt available, interrupt 0 and interrupt 1. It is available in pin number 16 and 17, that is PD2 and PD3. So it is available as INT0, INT1, INT2. Where is INT2? Here. Okay. So there are 3 types of interrupts. So along with other units like timers, USART, SPI, I2C, ADC, DAC, EPROM, analog comparator, interrupts are available. Okay. So each interrupt has a general interrupt control register. It is vary from 0 to 7. It is of 8-bit. Here you can see that 5, 6, 7 is dedicated to interrupts. Interrupt 1, interrupt 0, interrupt 2. It is when it is set, it has a value of 1. When it is reset, it has a value of 0. So bit 765 indicated to 3 types of interrupts. Okay. So 4 or 3 will not be used. It is user programmable. 1 and 0. What is bit 1? That is IVSCL. If it is basically it represents the vector interrupt. Okay. Vector interrupt will be used by these types of bit. Okay. So bit 0 basically IVC. If 1 enable, if the value of this is 1, that means this particular bit is selecting. So basically when we are executing the data, sometimes we need to store the value in our interrupt registers. So this is all about the AVR microcontroller. In our next lecture, we will start with the unit number 2, that is MCP 430. Thank you everyone. Thank you everyone for your patience.